Welcome to the 12C R1 Rack Installation Cookbook video, where we will be installing 12C R1 on Linux without GNS. This is a 5-part video series where we will be walking you through the installation and configuration of 12C R1 from the OS configuration all the way through the database creation. So whenever you finish this cookbook video, you will have a fully functional 12C R1 cluster. This is part 1A of the OS configuration. The OS configuration is broken into 2 parts due to a MyOracle support video file upload size limitation. So part 1A covers the first half of the OS configuration. Part 1B covers the second portion of the OS configuration. A little bit about the demo installation. We'll be installing on Oracle Enterprise Linux 6.4, running the UEK kernel version 2639. This is a 4-node cluster. The node names are CEtrain21, CEtrain22, 23, and 24. Installation details, again, we're installing 12.1.0.1.0 grid infrastructure using FlexASM without GNS. Before you begin, this demonstration video is not a replacement for the Oracle product installation manuals. It is meant to supplement those manuals, so it's highly recommended that you go ahead and you review the installation guides for your particular platform prior to beginning the installation itself. I would also recommend that you review the Oracle Clusterware Best Practices and Starter Kit MyOracle support notes. They're each entitled Rack and Oracle Clusterware Best Practices and Starter Kit. There is a platform-specific note for each platform that Rack is supported on. There's also a platform-independent note which has recommendations for that cover all platforms. The first thing that we need to do is we do need to create user accounts. It is recommended for different users to be used for the installation of grid infrastructure in the Oracle Database Home. So this is the installation that we'll be performing in this demonstration. The grid infrastructure home will be owned by the grid user. The Oracle home will be owned by the Oracle user. Because we are in a role-separated environment, we will need independent Oracle bases for each of the users. So grid infrastructure will have its own Oracle base, as will RDBMS software. So step 1 is to create the OS users and groups using the commands user sbin group add -g group ID and the group name. So for this installation, we'll be using oinstall dba opper asm admin asm dba and asm opper. We will then go ahead and we'll create the users that own the Oracle software, respectively grid for grid infrastructure and Oracle for the database. To do this, we'll use the user add command, which is located in user sbin, -u user ID, -g the primary group, which is going to be oinstall. This is required, and -G the secondary group. For the grid user, the secondary groups are going to be ASM admin, ASM DBA, ASM opper. For the Oracle database software owner, the secondary groups will be DBA and ASM DBA. Once we have done that, we'll change the password for each of the respective users, and we will then repeat steps 1 through 3 on all cluster nodes, ensuring that the user ID and group ID are identical on all nodes. This is very important. Alright, let's go ahead and create our users and groups. So the first group that we need to create is oinstall group ID 501. Second is DBA group ID 502. Third is opper group ID 503. Fourth is ASM admin group ID 504, ASM DBA group ID 505, and ASM opper is the last group that we need for our role separated environment. That's group ID 506. Let's go ahead and create our users and assign them to the appropriate groups. So the first user we'll create is user ID 501, which is the grid user. Primary group oinstall, secondary groups ASM admin, ASM DBA, and ASM opper. And group ID 502, primary group oinstall, secondary groups ASM DBA and DBA. Now we'll go ahead and we will validate that we properly created our users. with the ID command, and we'll reset our passwords for those users. We'll repeat this on all cluster nodes, making sure that we use the same user ID and group ID on each of the nodes in the cluster. Now that we have created our users and groups, let's go ahead and talk about the network requirements. Network requirements and network best practices for grid infrastructure and rack. Just a minor note, this install demo is not using GNS, so we're not going to be covering GNS network configuration in this demonstration video. General requirement notes: each node in the cluster must have at least 2 network interfaces or 2 physical network adapters, one for the public network and one for the cluster interconnect network. Redundant network switches in NICs are recommended for high availability of the public network. For the public network, bonding may be used to facilitate this at the operating system level. For the private, HAIP is preferred for any system that's running 11.202 databases and above. HAIP was introduced in 11.202. Pre-11.202 databases do not understand HAIP, so keep that in mind when planning your network redundancy. Public and private interface names must be identical on all nodes of the cluster. So if the public interface is ETH0 on node 1, the public interface on all cluster nodes must be ETH0. The network adapter for the public interface must support TCP/IP. The network adapter for the private interface must support the UDP protocol using high-speed network adapters, so gigabit Ethernet or better is what's recommended. We also support 10 gig as well as InfiniBand. For the private network, endpoints of all designated interconnect interfaces must be completely reachable on the network, on the interconnect network. Every node in the cluster should be able to connect to every private network interface in the cluster. Host names must conform to the RFC 952 standard, which permits alphanumeric characters. Host names using underscores are not allowed. I would recommend that you review notes 811.306.1, Rack and Oracle Clusterware Best Practices and Starter Kit for Linux, and note 810.394.1, which is the platform-independent Rack Best Practices and Starter Kit. This will provide you with a comprehensive list of networking best practices that pertain to Rack. IP address requirements. Require 1 public IP per cluster node. The host name assigned to this IP is to be resolvable via DNS and should be entered in etc host on all nodes. Require 1 virtual IP per cluster node. This virtual host name that is assigned to the virtual IP is to be resolvable via DNS and should be entered in etc host on all nodes. We do require a minimum of 1 scan IP, but 3 scan IPs is recommended. These 3 scan IPs need to resolve to a single DNS entry round robin. If more than 1 scan IP is in use, the IP must not be entered in etc host. It should only be resolvable via DNS. etc host does not support name resolution to multiple IPs. We require 1 private IP per interconnect per node. This does not need to be registered in DNS, nor does it need to be entered in etc host. If HAIP is being used, each interconnect NIC must have an IP assigned. The public IP, virtual IPs, and scan VIPs must all reside on the same subnet. The VIPs and scan VIPs must not bind to any specific network interface prior to the grid infrastructure installation. These IPs should not be pingable, in other words. Grid infrastructure will actually plumb these IPs to the designated public interface on clusterware startup. IPs within the 169.254 address range should not be assigned on the systems. They should not be running anywhere on the systems. This address range is defined as link local per RFC 3927 and is only used for dynamic network configurations. For HIP, each interface in the HIP configuration is required to be on separate subnets for proper failover. Details around the separate subnet requirement can be found in note 148.148.1.1. larger network topology. Private networks should be deployed on gigabit Ethernet or better. Why? Why are we emphasizing these 3 points? For the fact that latency is a big factor in the overall performance of the database. So to ensure the lowest latency possible, we recommend keeping the private network as simplistic as possible. It is highly recommended that redundant NICs are configured. For 11.202 and above, having no pre-11.202 databases, HAIP should be used for private network redundancy. For systems running pre-11.2 databases, the Linux bonding driver should be used because HAIP is not recognized by pre-11.202 databases. When implementing the Linux bonding driver, mode 3 and mode 6 must be avoided. They're problematic for various reasons. For details, see My Oracle Support Note 811.306.1. Jumbo frames for the private interconnect is a recommended best practices to enhance performance of cache fusion operations. For details around this, see My Oracle Support Note 341788.1. And again, I would recommend that you review the platform-specific Linux Starter Kit and Best Practices note, as well as the platform-independent Best Practices and Starter Kit notes for a comprehensive list of network best practices. Let's validate the network. So for this installation video, we do expect that the IP assignments and interface configuration has already been performed by sysadmin, following the guidelines that we just spoke about. So the first thing that we need to do for the network configuration is we need to ensure that the proper IPs have been plumbed to all the appropriate interfaces, and the interface naming for the public and private is consistent across all nodes in the cluster. We'll do that with the ifconfig command. We want to ensure that the public, virtual, and scan host names are properly registered in DNS. We'll use the nslookup command for that. And we also need to populate etc hosts with the public and virtual host names. Do note that we are not placing scan in etc hosts. It must be in DNS to resolve to 3 IP addresses, which is the recommended configuration. We'll go ahead and perform this network validation quickly. We will use the ifconfig -a command to validate our IP configuration for each node in the cluster. ETH0 is our public interface. ETH1 is our first private. ETH2 is our second private interface. So we need to make sure that each of those interfaces have proper subnet alignment across the cluster. So we can see that ETH2 on node 2 and node 1 are on the same subnet. ETH1 on node 2 and node 1 are on the same subnet. And finally, ETH0 on node 2 and node 1 are on the same subnet. Do the same validation for the third node in the cluster. Again, ETH2 is on the same subnet as ETH2 on the other nodes. ETH1 is on the same subnet as ETH1 on the other nodes, and ETH0 is on the same subnet as the other nodes. So now let's validate the DNS configuration with the nslookup command. Again, the public host name, the virtual host name for each node in the cluster needs to be in DNS, as well as scan. We'll use the nslookup command as shown here to perform that validation. Now let's populate etc hosts. etc hosts needs to have the public IP resolving to the public host name, the virtual IP for each node in the cluster resolving to the virtual host name, so we'll go ahead and type this in now. While we're typing here, do remember that the scan virtual IP should not be registered in etc hosts. It is required to be in DNS, especially if you are trying to define more than one scan virtual IP behind the scan name. It cannot be in etc hosts. Okay, so that's all of our hosts. We'll save that off, and we're going to copy that to the remote nodes in the cluster with a simple scp command. Okay. Now that we have validated our network and made any changes that are necessary, let's go ahead and talk about the OS software and kernel parameters. So there are two options to configure the OS in preparation for a grid infrastructure and rack installation. The first option is to utilize the Oracle RDBMS pre-install RPM. For Linux 6, the pre-install RPM can be obtained via Yum, and it is named the Oracle-RDBMS-server-12C-R1 pre-install. For Linux 5, you will use the Oracle-validated RPM. Regardless of the version, the following is performed by this pre-install RPM. Creates the OInstall and DBA groups, which are the required minimum groups. If you want role separation within your environment, you must manually create the groups. Also creates an Oracle user, which is the minimum requirement. Again, manual creation is required for role separation. And installs all OS packages that are required. Configures all kernel parameters per the requirements. And it also configures the shell limits for the Oracle user. If you're installing on a role-separated environment, you may need to add the limits for the grid infrastructure user. Explicit instructions for utilizing the Oracle RDBMS pre-install RPM can be found in Chapter 3 of the Grid Infrastructure Installation Guide 12CR1 for Linux. For this installation, we're going to be using the second option, which is the manual method of configuring the operating system. This was basically chosen to provide you with a better understanding of the configuration necessary to install rack the OS configuration. And it also allows for customization of the parameters from the recommended minimums. OS parameters. So the kernel parameters listed here in this demonstration are the recommended minimum values. Tuning of these parameters may be necessary depending on the environment. The latest information on grid infrastructure parameter settings for Linux can be found in Note 169.706.1 as well as in the Oracle Grid Infrastructure Installation Guide for 12CR1. So all the steps here are obviously going to be performed as the root users when making system configuration changes. So step one is to add the recommended kernel parameters to etsysctl.conf. They're listed below. If you have higher values already in your etsysctl.conf file, the higher of the two values should be used. Once the entries have been placed in the sysctl.conf file, you'll run sysctl-p as the root user to allow the new kernel parameters to be put in place, and you'll repeat steps 1 and 2 on all cluster nodes. So we'll go ahead and perform that configuration now. Let's go ahead and edit the etsysctl.conf file with the VI editor. Go ahead and add our required kernel parameters. We're going to put a comment in here that it was the minimum required for 12CR1. And we're actually going to cut and paste because it's a little bit easier. So we'll save that off, and we're going to copy that sysctl.conf from node 1 to all other nodes in the cluster to ensure that we have a consistent configuration. Okay. Now we'll go ahead and we'll execute the sysctl-p command. On each node in the cluster. We can do this through SSH, which is a little bit easier than logging into each node through a separate console. And that takes care of our kernel parameters. Now that we have put in place the proper kernel parameter settings, we're going to go ahead and install the OS required software. The OUI and or ClueVerify, which is run by the OUI, will check for missing packages during the installation, and you will have the opportunity to install them at that point. during the pre-checks. But you may want to still validate that all the required packages have been installed prior to launching the OUI. It eases any burden placed upon you to exit the OUI, lose your OUI window, etc. So it's best to actually ensure that all the packages are installed prior to launching the OUI. The requirements below are for 64-bit versions of Oracle Enterprise Linux 6 and Red Hat Enterprise Linux 6. The requirements for other supported platforms can be found in Note 169.706.1, as well as in the Grid Infrastructure Installation Guide. The software requirements listed here are those that we are going to install. So step one, we're going to validate the required RPMs. So we're going to use the yum list command. We're just going to list out all the RPMs. It'll produce a nice tabular formatted screen output, and you can see exactly what's missing. We'll then install any of the missing packages. And the example that I show, I actually do a yum install -y and allow any already installed packages be ignored. So if you try to install a package that's already installed with yum, it'll actually ignore that package. So we just list them all out, and then we'll go ahead and we'll repeat those steps. Let's use the yum list command and list out all of the packages as arguments to that command. This will tell you what's installed and what is not. So you can see that if a particular package is installed, it gets labeled with installed in the far right hand column. Those that are not installed will have OEL6_latest, which is the channel that that package is resides in. To install the packages, we will use the yum install command, and we'll simply list out all the packages here. Any package that is already installed will be skipped, and those that are not installed will be installed along with their dependencies. The command does download and install the packages all in one shot. Once this is completed, we will go ahead and repeat this step on all nodes of the cluster. You can actually do it in parallel if you choose. For sake of time, we are not demonstrating this on all nodes of the cluster, just on a single node. Moving on to the user shell limits. The first step, as far as user shell limits go, we need to validate that the etcpm.d login contains the session include system-auth. If it does not, we need to add it. You can edit the file with VI, or you can do the echo or double quote session include system-auth, double quote, redirect that out to etcpm.d login. We also want to validate that the etcpm.d system-auth file contains session required pamlimits.so. If it does not, we need to add it. And then we can finally configure our limits. The way that we're going to do this is we're going to place a file under etcsecuritylimits.d called oracle_limits.conf. And we will place the hard and soft limits for the grid infrastructure user and the Oracle user within this file, and it will be picked up. So our limits, our required limits are no file soft 1024, no file hard 65.536, nproc soft and hard 16.384, soft stack 10.240, hard stack 32.768. Once the shell limits have been set, we'll validate the shell limits by logging into the system, and we'll use the ulimit command. When we log into the system, we'll log in as grid and Oracle, and we'll simply execute ulimit minus capital S is for the soft limit, capital H is for the hard limit, lowercase n is for no file, the U is nproc, and S is stack size. So you can go ahead and validate those with the commands listed there as the respective Oracle software owner or grid infrastructure software owner. And we'll repeat steps 1 through 4 on all cluster nodes. Let's go ahead and do that in a demonstration screen here. To use our shell limits, we first want to make sure that the etcpm.d login file contains the session include system auth entry. We use the grep command to find that out. If it does not, please add it. We'll then grep to see if pmlimits.so exists in the etcpm.d system auth file. As you can see, it does. If it does not, please add it. And we will now create a file under Etsy security limits.d named oraclelimits.conf, and we will go ahead and paste our required hard and soft limits for grid infrastructure and Oracle within that file. Save off that file. We'll validate the changes by SUing to the software owner, in this case grid infrastructure software owner, grid, and we can see that all of our limits are set properly there for Oracle and grid infrastructure users. And we'll go ahead and we will repeat that procedure on every node in the cluster. Now that our OS parameters and packages have been properly installed, it's time to talk about time synchronization. So we do need to ensure that the date and time setting on all nodes is set as closely as possible. So it needs to be in sync across the cluster as close as possible. You can do this using NTP with -X option, which enables slewing. So instead of stepping the time forward or backwards to make clock adjustments, it'll actually speed the clock up or speed the clock down. This is required for grid infrastructure because backwards time shifts can cause node evictions. If you do not want to use NTP or don't have a time source, you can use CTSSD. If you want to use CTSSD, you must disable NTP and remove the NTP configuration from all nodes. For this installation, we are going to implement NTP-X. This is the more common configuration, as many customers do want their time synchronized to a standard time source, whereas CTSSD synchronizes the time across all cluster nodes from a single node in the cluster, which is called the reference. So step 1, we'll edit this Etsy sysconfig NTP file, adding the -X to the options variable, and we'll go ahead and restart the NTPD daemon. And we'll repeat that on all cluster nodes. First thing we need to do is stop the NTP daemon with service NTPD stop. Now that it's stopped, we'll edit the NTP conf file, which is under Etsy sysconfig NTPD. We'll add the -X option to the arguments for the options. We'll save that off and we will restart NTPD. And we will validate with a PS-EF grep NTPD. And we can see the NTP is now running with the -X option, and we will go ahead and we'll repeat that on all nodes of the cluster. The next step in our OS configuration is to disable IP tables and the Avahi daemon. So both of which are known to cause issues with rack installation. So the Linux firewall, obviously we depend heavily on the private network, and we use various ports on that private network. So the Linux firewall tends to cause communication issues. So we're going to shut that down as a best practice. The Avahi daemon is an MDNS daemon. Grid infrastructure starting with 11.2.01, we package our own MDNS daemon. In this configuration, MDNS is actually going to be used to push the GPMP profile, which is required information for each cluster node to join the cluster. So we're going to disable that. We will also disable SE Linux. That's on the next slide. So the first thing is to shut down and disable the Avahi daemon. So the way that we do that, service Avahi daemon stop, and we do a check config Avahi daemon off. We'll shut down and disable the IP tables. You can see the commands to do so there. We'll shut down the IP6 tables also. And we'll repeat steps 1 and 2 on all cluster nodes. Let's go ahead and disable the Avahi daemon and shut it down. So service Avahi daemon stop will stop the Avahi daemon. And check config Avahi daemon off will disable the daemon on boot for all run levels. Now let's disable the IP tables. Same method, service IP table stop. And IP6 tables, service IP6 tables stop. And we'll go ahead and we'll disable those from boot at all run levels. So check config IP tables off and check config IP6 tables off. And don't forget to do this on all cluster nodes. We'll now go ahead and disable SE Linux. SE Linux is supported, but the recommendation, if possible, is with SE Linux disabled. If you plan on utilizing ACFS file systems, SE Linux must be turned off. ACFS does not support SE Linux. And there's a reference bug, which is bug 1275444. To disable SE Linux, you'll edit the etc SE Linux config file. You'll set the SE Linux parameter to disabled. You'll go ahead and you'll reboot the server, and you'll repeat steps 1 and 2 on all cluster nodes. We'll edit the SE Linux config file at etc SE Linux config. Change SE Linux from permissive to disabled. Save that file off, and we'll go ahead and reboot the cluster node. And we will then repeat that on each node in the cluster. Okay, the OS configuration part A is now complete. We'll move on to part B of the OS configuration. Once we complete part B of the OS configuration, we will then move on to the grid infrastructure installation.